In this class number 4, we are going to study quickly the working pressures of the R134A refrigerant and some of its characteristics. Let's start by saying that the R134A gas is used both in refrigeration and freezing as well as in conditioning applications for a temperature of -20 degrees Celsius in the typical evaporator. Freezing equipment, about 4 degrees Fahrenheit. We are going to have in the evaporator, we need to have in the evaporator a pressure of 0.32 bar to 4.7 psi manometric. For -20 degrees Celsius, we are going to need 4.7 psi manometric. Now for a temperature of -10 degrees Celsius, -10 degrees Celsius, about 14 degrees Fahrenheit, we are going to need in the a pressure of 1 bar equivalent to 14.7 psi. For a temperature of -5 degrees Celsius in the evaporator, about 23 degrees Fahrenheit, we are to need in the evaporator 1.42 bar, that is, 20.87 psi manometric. These previous values are for freezing and refrigeration applications. For air conditioning, the R134A refrigerant gas is used, but in the automotive sector, not in refrigeration equipment. The R134A is seen quite a lot in water coolers for air conditioning applications, that is, but it is not seen in direct air conditioning equipment, but in water coolers, and then the water is used to cool the air. So that's where the air conditioning application is. For a temperature of 5 degrees Celsius, about 41 degrees Fahrenheit, the pressure on the pressure must have about 2.49 bar, close to 36 psi. Those would be the pressure values most used with the R134A refrigerant gas. Without failing to mention that at high, for an environment of 30 degrees Celsius, a temperature of about 40 degrees Celsius, equivalent approximately to 104 degrees Fahrenheit, we are going to about 9.18 bar, with values close to 135, 134 psi. When the equipment is off, the two pressures are leveled, there is no suction, there is no. So for an environment temperature of 30 degrees Celsius, about 86 degrees Fahrenheit, the pressure. Both pressure gauges should show must be close to 6.7 bar, equivalent to 98.49 psi. These are the main pressures, both at low, at high, as the equipment is off, with which the R134A gas works. Its global heating potential is 1430, the GWP. What happens? This value is still a value that allows the R134A to still be used in many equipment. But in the automotive sector, the R134A refrigerant gas, although it does not damage the ozone, has already been replaced by the GWP. It has been replaced by the R1234JF gas. But we are going to see many cars with R134A gas, so it is still marketed without any problem. But in the new vehicles we will no longer see this gas. As for the oil with which the R134A works, it is very important to know that it works effectively. POE oil, with fairly low viscosities, as the compressors are mostly for refrigeration and freezing. Piston compressor is still used a lot. We are going to see low viscosities, such as POE 10, POE 22, and POE 32, where we are going to more the POE 22. It is the one that we are going to observe the most, then the POE 32. For the automotive part, POE oil is no longer used. We are going to use the PAC oil, PAG, PAC in the automotive part. The R134A refrigerant gas is a gas of very good performance, especially for refrigeration and air. When we compare it with the performance of the R404A in freezing, already from -20 it had a better performance than the R404A, but for medium and high temperatures the R134A worked a little better. As for the comparison with the R600A, it has the strength of the R134A, which is non-flammable. Therefore, it can be used without any inconvenience. So that would be the most important information about the R134A gas.